All right, good morning.
Cosmology.
Okay. All right, good morning. Um, my name is Harry Ricker. This is the Cosmology Discussion Group meeting for February 22nd, 2026. And I'm going to give a talk on quantum cosmology. So I want to thank everybody for coming by. Okay, is this good? Can you see
Yes.
Yep.
presentation?
Yeah.
Okay, I'll start off here by saying the reason I got interested in this, I was reading a book by Frank Tipler called The Physics of Immortality. Have any of you people heard of this book, The Physics of Immortality by Frank J. Tipler?
Mhm.
Nope, nobody's heard of it. Wow, okay. Anyway, I've had this book for quite a while, and I started reading it, and he talks about quantum cosmology, and I didn't know what that was. So I started looking into it to find out what quantum cosmology is. And so the purpose here of this talk is I'm going to try to provide an introduction to the physics. That this is an area of physics that attempts to unify quantum mechanics, general relativity, and cosmology. That's kind of a general idea of what they're doing. Um, provide a background so that you can understand the new ideas and terminology being used by the physicists today. Now, there's a lot of YouTube videos about this topic, and if you're not really familiar with quantum cosmology and what it is and what they're talking about, it all seems kind of obscure. So, one of the ideas of this talk is to help you introduce you to what it is that they're talking about. Stimulate a desire to learn more about strange new ideas so you can make informed judgments. Now, we're going to get some strange new ideas here. All right, so what is quantum cosmology? This is the official definition. Quantum cosmology is the study of the universe as a quantum system. That seems kind of strange. Applying quantum mechanics to understand its origin, evolution, and structure. That's kind of a vague definition. Quantum cosmology seeks to merge quantum mechanics with general relativity to describe the universe at its earliest moments, where classical physics breaks down, such as near the Big Bang and during the Planck era. Unlike classical cosmology, which treats space time as a fixed deterministic background, quantum cosmology treats the universe itself as a wave function. That's the key. That's the key, allowing for probabilistic descriptions of cosmic evolution. All right. Well, that's a lot of jargon, I think. So maybe there's a simpler way of looking at it. And I went through a lot of books. So what is this quantum cosmology? And I went through my library, went through the bookshelf and picked out a lot of books, looked up in the index quantum cosmology, and didn't really find a lot, but sometimes I did. And some of the so you could sort of say that really what they're doing is they're applying the mathematics, and that's a key statement there, the mathematics and methods of quantum mechanics to problems in cosmology. That's kind of what they're really doing, but it doesn't really mean a whole lot to say that unless you have some examples. Um, one of the areas where one of the examples where this is done is in the physics of the earliest moments of the Big Bang. Okay, so um, Hawking um, and Hartle did this. And the idea is you get rid of, is to avoid the singularity problem. And I'll talk that more about that later. So they're working on a way to avoid the fact that the general relativity equations produce a singularity. And this occurs in black holes and at the Big Bang. So this is kind of their way of getting around the difficulty, if you will. And so that's one of the areas of application. Another area is um, physics of gravitational waves and the graviton. So in Weinberg's book, that's what he talks about as far as what quantum cosmology is. But that book is kind of old, and so maybe not. That's just one area where you could really talk about quantum cosmology is gravitational waves, and you have gravitons. Another area where you might talk about quantum cosmology is during the inflation. And of course, now it's questionable as to whether or not there really was an inflation. Of course, it's also questionable whether there really was a Big Bang. But this really gives quantum theorists an opportunity to get in there and apply their mathematical techniques and do publish papers and give talks on quantum cosmology. And of course, we have the quantum processes that occur in the Big Bang, and that's really the probably the earliest application of what you might call quantum cosmology. All right. Um, this seems to be the main point, the universe as a quantum mechanics wave function. That seems to be the holy grail of what they're trying to do. And it really seems like the universe isn't a quantum system. So applying the idea of quantum mechanics and treating the universe, which is a very, very, very large system, you know, the most macroscopic of all macroscopic systems, and to take a theory that's a microscopic theory of physics and apply it to the universe seems not really to make a whole lot of sense. So it's obviously a bold assumption that the universe is described by a wave function, as in quantum mechanics, but that's really what they're trying to do. And really the goal, if you will. This line of thinking seems to arise from here's the whole key point. The line of thinking seems to arise from the idea that quantum mechanics is the best physics theory, and all physics needs to be consistently unified with QM. And so what you'll see is you go on the internet, all these guys that are proponents of QM, and they'll go, it's the most accurate theory that we have in physics. It's our best theory. It's our greatest theory. And if you have the best and greatest theory, then it seems like you ought to be able to apply it to everything in physics. And if it doesn't apply to cosmology, then you've got to try to find a way to make it apply to cosmology. So that's really, I think, what their motivation is. Quantum mechanics is the best theory. It's our greatest theory. It's our most wonderful theory. And it's got the most beautiful mathematics when we have to make it work to apply to everything. Everything in physics has to be derived from the principles of quantum mechanics and the mathematical techniques that quantum mechanics has. So, but we have this problem, which is that QM is a statistical theory of probability, and it makes quantum cosmology seem illogical as the universe becomes merely a chance happening. That's kind of my thought when I'm reading about this, and I'm thinking, like, how can you talk about the universe and how it came into being if it's really just a chance thing. So that seems to be kind of something that they don't really want to address. All right. Um, uh, this is sort of an overview of chronology of how this area of physics, if we will, if you want to call it an area of physics or a study of study area. Um, in the 1920s, we have the quantum mechanics. Now, they use the word first quantization. I find that kind of interesting. Um, so you had Schrodinger equation and the foundations of QM. So that takes place in the 1920s. And then you had Heisenberg's um, uh, matrix, matrix mechanics, and they made a lot of progress. And then by the 1930s, Dirac um, made it relativistic, made quantum mechanics relativistic. And then, of course, then you had quantum electrodynamics was developed. So quantum mechanics was pretty well developed by World War II. Now, in 1948, we have the Big Bang. And I talked about this. Um, uh, Gamow is and his students, Alper, as I recall, Herman Alper, can't remember all their names, but anyway, they came up with the equations, and they predicted the temperature of the Big Bang, and then they predicted that as the universe expands, the temperature would go down. And then later in the 1960s, they discovered the microwave background radiation and jumped on the idea that this proves the Big Bang. Okay. And that's kind of the position that they're at today. Um, Now, that requires quantum mechanics, okay, to do those calculations. That's the point. Okay. The next point is 1957, Hugh Everett III came up with this many worlds interpretation, in which he proposes a state vector or wave function for the entire universe. So it seems to me, based on my limited knowledge and understanding, and trying to look into this problem, that his paper kind of is a fundamental type paper where he talks about the wave function for the entire universe. Now, I don't know that anybody before him did that. Maybe somebody did, but he seems to be the um, kind of a founding father of quantum cosmology, if you will. And he's kind of an important guy, and you may dislike his theory, but essentially he's an important figure in the story. Um, the next thing we have here on the chronology is in 1967, Wheeler-DeWitt equation quantizes general relativity. So this was, I guess you could say, a big breakthrough in the creation of the Wheeler-DeWitt equation, where general relativity is essentially brought into the quantum theory by quantizing general relativity. I'm not sure that's a good way of talking about it, but I guess from their point of view, this is an important thing. They've created a mathematical formulation that makes general relativity quantized. So they bring general relativity into the quantum um, paradigm, if you will. But there's a problem. And the problem is they didn't know how to solve the equation. They had this equation, okay, but they didn't know how to solve it. Okay, so that's kind of a problem. Now, in 1983, this is a kind of another milestone event, if you will. Stephen Hawking. We all know Stephen Hawking. Everybody probably has heard of Stephen Hawking. And then this guy, James Hartle, okay, who I'll talk a bit more about later. They apply the uh, quantum mechanics universal wave function to resolve the singularity of the Big Bang. So this is considered a very important paper. And if you go on the internet, there's videos that talk about this. Okay, 1986. Now, I mentioned Kepler's book. Uh, Now, there's this other book that I had. I didn't realize what this book was really about. And it's called Quantum Concepts in Space and Time. And it's published in 1986. Now, I think this is kind of an important book because all of the big players in quantum cosmology, except for maybe Hawking, have papers in this book. And one of the things I realized after looking into this is that all the big names have papers in this book. And so you might say this is maybe an important book or a milestone book. There may be other books, but I thought it was kind of interesting because I had it in my library and I tried to read it, but I didn't really understand it. And it's actually more understandable after knowing a little bit about what quantum cosmology is and what it's about. So that book was in 1986. Also in 1986, this guy, Abe Ashkatar, and it's probably a name nobody's ever heard of, discovers a way forward to solve the Wheeler-DeWitt equation. So you see, it's like, let's see, 1967 to 1986, that's like 20 years. So it took them that long, 20 years or so, to even begin to solve the Wheeler-DeWitt equation. And so that's a kind of a milestone, if you will. And then in 1990, they 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 had what's called the Kodama state solution for cosmology. So they making more progress after the 1986 to 1990. Now they've got the mathematics sort of working. They say, hey, yeah, now we've got a mathematical way of solving the quantum cosmology problem. So they're making progress. But it would seem that that was a long time ago, and they still really haven't solved this Kodama equation. What they're really doing is they're finding mathematical ways to simplify the problem through approximations, and I think that's really what they're doing. Okay, now in 1994, um, this book came out, the Physics of Immortality by Frank Tipler, which I think's an interesting book, and um, he bases his argument on quantum cosmology to a large extent. So it's an important part of his book and his argument that he presents in his book. And as I pointed out when I read the book, I thought, what is quantum cosmology? So that figures in importantly in his book. And then, okay, so in 2020, there's this quantum cosmology has gotten to the point where James Hartle published a series of essays. And I guess I haven't looked at it, and I looked at trying to buy it, and it's like one of these books. It's like $150 or something like that, real expensive. But I think if you were interested in seriously pursuing quantum cosmology, you'd probably want to get this book by James Hartle. Now, remember, James Hartle was the guy that published the important paper with Stephen Hawking, and we'll talk more about him later. Okay, so here are the famous people who worked on quantum cosmology. Now, the reason I'm talking about this is, um, you know, um, these names don't really seem that, if you don't know who these people are and what they're talking about, you just go, well, there's another guy just talking. And there's a lot of YouTube channels. These guys are on YouTube a lot. They have YouTube videos. So James Hartle, I mentioned him. He's called the father of quantum cosmology. Wow. He's the father of quantum cosmology. And, that primarily goes back to his work with um, Stephen Hawking when he published that paper that I mentioned. And so he's a big player. Now, apparently he died in 2024, but there are YouTube videos where you can go on there and he gives interviews, which is kind of interesting. You can go on YouTube and search James Hartle and find interviews with James Hartle or lectures that he's given. So that's good to know. Of course, Stephen Hawking. I guess everybody knows who Stephen. Does anybody not know who Stephen Hawking is? I'm joking around. Now, I didn't realize that, I always thought Stephen Hawking was famous for black holes, but he's called a cosmologist. And of course, they made the movie about him, and he's famous for being an atheist and God doesn't exist. And that's pretty apparent in this movie that they made. It's kind of um, uh, anyway, I've seen the movie. I wasn't really particularly impressed. Then there's John Wheeler. I think everybody's probably should have heard of John Wheeler, who's a famous. There's a famous book on gravitation. Wheeler, Misner, and somebody else, and he's a well-known name. I think his interest, he's not really associated so much with um, quantum physics, but he's involved. He's got his name on the Wheeler DeWitt equation, and it turns out that this guy DeWitt apparently did some important work in quantum mechanics um, prior to the Wheeler DeWitt equation. He did some published an important paper in 1952, and I don't really know a whole lot about him, but anyway, Bryce DeWitt, that's his name. Bryce DeWitt derived the equation quantizing GR. Now, apparently, people say on these YouTube videos that the equation was really um, discovered by DeWitt. And I guess Wheeler uh, helped him out. I'm not really clear about that, but it looks like Bryce DeWitt really was the one who came up with this equation. And so he's an important guy in the story. Then, of course, Roger Penrose, um, he edited the book, Quantum Concepts in Space and Time. I don't think he's such a, how should we put this? Roger Penrose has videos in which he declares that quantum mechanics is wrong. So it's kind of hard to see Roger Penrose as a proponent of quantum cosmology, but he's apparently did play an important role in the past. And he I think it's interesting that he says quantum mechanics is wrong, but I think Roger Penrose is more uh, known for his work in general relativity and black holes and stuff like that. And of course, I've talked about in a lecture that he has a theory of the universe, a theory of the cyclic universe that he's been promoting. So, but I don't think he's really a proponent of quantum cosmology because he says that quantum mechanics is wrong. Okay, now we have Hugh Everett. Of course, that's a name maybe you might all be familiar with. His claim to fame is the many worlds interpretation. And as I pointed out earlier, he seems to have introduced this idea of a quantum wave function for the universe. And it's not real clear to me that he's the first to do that, but it does seem that he's associated with that concept pretty strongly. Then Frank Tipler, which I mentioned a couple of times, wrote the book Physics of Immortality. I'm not sure he's really that popular on YouTube. I haven't seen any videos about him on YouTube, but I think maybe he's not really a big name in this. Then down at the bottom, we have David Deutsch. David Deutsch has more videos on YouTube than you can shake a stick at. And he's a big proponent of parallel universes and the multiverse. And he's also has a paper in the book, Quantum Concepts in Space and Time. He's also, so he's a player in this quantum cosmology. All right. I'm kind of running out of time here a little bit. I better move faster. Okay, so here's what the whole point is. Quantum mechanics are going to just make a few points about it. The fundamental principle is reality is created by the act of observing. And that seems to be one of the big problems, one of the big issues. And so you might say, how does an observer observe the universe when the observer is part of the universe? And this is kind of an issue. And they have a way of explaining around this, but I'll just leave it at that. The second is the reality is produced. It's a statistical theory. Quantum mechanics is a statistical theory, and so the equations describe averages or ensembles. They don't really describe a particular event, and so this is kind of an issue. Like the creation of the universe is not a if you have let me put it this way. If your theory is statistical and requires an ensemble average, then you have to talk about multiple universes to have quantum mechanics be meaningful. That's really kind of the point I'm getting at. And okay, then the other issue is the entanglement issue, but that doesn't seem to really play too much into quantum cosmology from what have been able to gather. Okay, so trying to make sense of how these principles can apply to the universe is kind of an issue, and I'm not here to explain it or to pontificate about it. I'm just pointing out that these issues exist. Okay. Uh, then there's this book called Perfect Symmetry, where he talks about the Hartle-Hawking paper, and it assumes the origin of the universe can be treated. The origin of the universe can be treated like other quantum events. Now that's yeah. This gets you back to the problem of how can you treat the Big Bang as a quantum event when quantum events are statistical. That's to me that's kind of a strange idea. Okay, and the theory basically talks about how space and time are going to be created. Don't really see how that's possible or what they're talking about, but that seems to be what they're talking about. And the idea is it proposes a ground state wave function for the universe, and then um, basically you can calculate um, the probability for the universe coming into existence. And the whole point of doing this is to get rid of the singularity. That's the whole point. And you can do this in black holes. We get rid of the singularity. We turn this problem, this difficulty that we have in general relativity, that these singularities exist where the equations become meaningless. And what we can do is we can bring in quantum mechanics, and quantum mechanics can avoid this problem. So this is really kind of, in my mind, a sort of way of avoiding a difficulty in um, the theory of space and time and moving the problem from a difficulty in the theory in Einstein's theory of general relativity and moving the difficulty into quantum mechanics. Okay, that's kind of my view of it. All right. Um, let's see here. I got a warning message, 10 minutes. I'm going to talk a little bit about Frank Kepler's book because this is what really basically led me to get involved in this whole issue. And Tipler is sort of asking the question: Is there a God? Science has found God. This is kind of like what it says on the back of the book. This is kind of the hook to get you to read the book. And what I found the most interesting aspect of it is he asserts that theology ought to be a branch of physics. How about that? With quantum cosmology an important part of his theological physics. So Frank Tipler, a physicist, is proposing that theology ought to be a branch of physics. I'm not very sure many religious uh, theologians or people who are experts on God and religion are going to adopt Frank Tipler's proposal that physics should be defining what theology is. But Tipler seems to want to insist on that. And
Well, can I
here's
interrupt
the
for a sec?
sure.
I would like to say that I feel that in the future, science will answer some of these questions about the spirituality side of
All
the
right. Well,
equations.
thanks
Anyways,
for
go ahead.
bringing that up because I don't think that's the case. But anyway, certainly not quantum cosmology is going to solve this problem. I think it brings up more problems than
No,
answers,
not
Frank.
this specific uh,
Well,
field of science, but science
that's a good
in general.
assertion on your part, but I don't really see that happening, and I certainly don't see that happening through. I don't. I didn't find Frank Tipler's argument about why um, theology should be a branch of physics to be particularly compelling. In fact, I thought exactly the opposite. I thought his book made it seem that God was really necessary to explain the absurdities that quantum cosmology and the ideas that he's talking about brought into being.
But
And
what about Rupert Sheldrake's?
let's not argue about it,
Yeah, okay.
please.
Yeah, okay.
I knew you were going to argue about it. We can argue about it in the next session. Okay, so kind of the main point that I think is the weakness really is if Tipler says he believes in the many worlds interpretation, which is the Hugh Everett theory, and I think that's I think that's really a weak point in the argument right there. As soon as we start talking about quantum cosmology and we have to bring in the many worlds interpretation and the parallel universes and the multiverses, I think that's where it gets weak. Okay. All right. Now I'm going to kind of try to sum up a little bit here. Um, the purpose seems to be what is this really all about? And I mentioned this in the beginning. I'm going to repeat it here. The purpose seems to be a desire to remove the dichotomy between quantum and classical physics by unifying under quantum mechanics principles. So, in other words, uh, we need a unifying theory that makes everything work, and they're really pushing hard to make that theory quantum mechanics. That the principles of quantum mechanics have to underlie pretty much everything in physics. That seems to be the underlying motivation that they're trying to obtain here. That seems the goal seems to be motivated by quantum mechanics is the best theory we have. It's the most accurate theory of physics. This sort of thing, and so that's their motivation and desire. We have the best theory. We should be applying it to all the problems of physics. Okay. But then there's the downside, the problems that come with it are the many worlds, the interpretation, the multiverse ideas, and the parallel universes. And to a lot of people, these ideas seem ridiculous and absurd on the face of them. So bringing in quantum theory and quantum ideas seems like a really good idea from the point of view of these people who are experts. And I think this is the important point. They understand quantum mechanics, they understand all this mathematical formalism, and they need to apply it. And because they're brilliant people, we're going to apply it to cosmology. And and make cosmology a part of quantum mechanics. That, to me, that seems to be what they're trying to do. All right, here's my thoughts on it. Quantum cosmology seems to be a way to avoid the singularity problem in the Big Bang. And then you also have the same problem in black holes. So that seems to be the main accomplishment, if you will, of what they've accomplished. It comes at the cost of introducing a different set of problems, which would be the many worlds, parallel universe, and multiverses. And it seems like the physics community is actually adopting these ideas or accepting these ideas. So there's a large, from what seen on YouTube videos, they keep saying, well, these ideas are really gaining acceptance. On the other hand, there's also vociferous opposition, if you will. So the physics community seems to be divided about the multiverses and the parallel universes and all this other sort of thing that seems to be required, that you have to bring them along if you're going to do quantum cosmology. And so that's kind of the downside of it. Now, then there's the final issue that I brought in by talking about Frank Tipler's book, which is um, science may not, that we may not have a rational answer as to why the universe exists. Okay. And maybe God's a better answer in the long run. But these guys don't seem to be doing a very particularly good job of it at the present time. So, looking at what they're saying and listening to what they're saying, it doesn't really look to me like physics is going to really have any really good answer to why the universe exists and why we as human beings exist in the universe. Doesn't seem to me that they're making any real progress on this issue. And okay, so I'm going to close with that being my final thought here. And uh, looks like we might have 2 minutes. So I finished up in 2 minutes. Well, I want to thank you all for listening to my little talk here. And I hope it was interesting. I hope it maybe gave you some insight into what this area of physics is about and what they're trying to accomplish. Okay, dead silence. Okay, you can go now, Rick, if you want to say something.
Oh, okay. Well, I'm just thinking that, trying to apply the sub microscopic world to the actual macroscopic world, it doesn't seem logical to me. And if you need this system to work, and you have to have multiple Earths and multiple universes, no, I mean, it's just wrong in my view.
Well, you're just repeating what I pointed out pretty much, which is that if you're adopting quantum mechanics and you want to try to make cosmology consistent with quantum mechanics, that comes with disadvantages.
Right. I say things a little simpler.
I think that was pretty clear. I mean,
Yeah.
it's
Yeah.
just not okay. And so
So,
the point I really want to make here is, and this is a very common thing if you go on YouTube. And I was surprised to find so many videos on YouTube. This guy David Deutsch, he seems to be everywhere, and Sean Carroll is another name. I didn't mention him. He's got a lot of videos, and they're promoting the many worlds. But it's hard to understand. There's the parallel universes. David Deutsch seems to be associated with parallel universes, and uh, okay. Like as I said before, as I was saying, um, parallel universe idea, the multiverse idea, um, it, it, they it's sort of required if you're going to adopt quantum mechanics as a paradigm. These ideas are required.
It seems
Okay.
to me to be an ad hoc.
No, it's actually, see, this is, getting into this argument. Um, it's the reason they are there is because of the way quantum mechanics has been constructed as a theory of physics. They're
Right.
they're they're embedded in quantum mechanics. So if you adopt quantum mechanics, you're gonna get these ideas are in there, and so and if you think about the parallel universe idea, so let's say when the universe is created, it's not one universe gets created. It's a whole ensemble of universes that gets created. So and then you say, well, because quantum mechanics deals with ensembles, it predicts the results for ensembles, an ensemble being a collection. Okay, so by talking about a collection of universes, that makes quantum mechanics applicable to it. Okay, do you
Yeah.
understand that?
Yeah. Yeah. And
That's the
another
whole
point.
point. So their whole if you're adopting quantum mechanics as your fundamental theory of physics, then you've dragged all these other what seem to be absurd concepts into the picture. The problem is, from their point of view, these things are required in order to make quantum mechanics work, and so it's perfectly logical for these ideas to be there. And so they're pretty much resistant to the notion that what they're talking about is wrong.
Of
So
course.
that brings the question to mind. Why is quantum mechanics the one and only game in town? Why is it the so-called greatest theory of all time? And what precisely is it? Because I'm still looking for a proper definition of, somebody that agrees with somebody else about what it exactly is. Can you help me out here, or at least shed your thoughts, perhaps, on why this is so important that this is the only game in town? Do you have any ideas on that?
Well, because it's a theory that's worked very successfully for them and they're wedded to it. I mean, it's just the greatest thing since sliced breads I mean, they're just, it's, yeah,
Well,
you've asked the real question. This is the real question. You asked it. You're asking the real question, the important question. You just asked it.
because I don't have an answer, but it is a question that's been playing in my mind for a while, if you will.
Well, that's why I
And
brought this presentation up
well,
because it's
thank you for the presentation. Loved it, enjoyed it. It's actually quite enlightening to see, a little bit about how things came into being. Yeah, so thank you for that. But if they claim it's so successful, how can you maintain such a claim, if you will? And I know this is opinionated, what I'm going to say, but how can you claim that when you're dealing with your model or theory, when you're talking about all these multi-dimensions? I mean, it is, to me personally speaking, again, opinionated, but it's just idiotic. How can you maintain this is physics if you're talking about multiple realities at the same time at an unknown number? Because a million is, tiny number if you relate it to limitless. So how how can this be?
I think it shows that there's a fundamental problem with quantum mechanics. I think that's really and they've been wrestling with this since, the 1930s or whenever Schrodinger and Einstein and Bohr had their argument. What does this mean? What is the meaning of this mathematical formalism? And and then Schrodinger came back with this uh, story of the cat, Schrodinger's
Right,
cat
right.
story, and he said that according to what they were maintaining, what Bohr's interpretation was, that the cat was not neither dead nor alive until it was observed by the observer. And that's really kind of where the real problem lies, because it's asserting really that reality doesn't exist until it's observed. And what
There
does
is a
this really mean?
concept, right? That is a quite modern concept, I think, that I hear more and more, and I don't agree with it at all. But there you go. Thank you for the presentation.
Yeah, it was a good one.
Another
Now,
thing that I observed as you were defining the whole concept is that it's the one theory that assumes what it wants to establish. I mean, it assumes a theory of the universe and cosmology and the origin of the universe and the Big Bang and expansion and all that, and it's trying to integrate that. So it's not saying we're looking at the universe to see whether some of these concepts are true or not. It's assuming them to be true. So it's begging the question, actually. It's really more of a theology, perhaps, than a science, one might say.
that brings it, that's kind of why I bring up Frank Tipler. Tipler says theology ought to be a branch of physics, which kind of to me says, we as physicists know better than theologians and people who believe in religion. And our assumptions and our theories about what is real are superior to other theories about what is real and what's important. And, it's a kind of an arrogance, which is why, I don't really adhere to it. And I think you ought to be um, suspicious of it when they claim, we're so arrogant, we can claim, that we know, we can answer the question that people have been struggling to answer since time immemorial, but we reject the God hypothesis. We reject that out of hand.
How can that be? In the end, I think there's something to say for that statement, and agree with you in principle. But for the statement of the gentleman you pointed out, the religion and the theoretical, cosmological, quantum cosmology, whatever, because the Big Bang, what else is it but an act of God, right? I mean, in the end, um,
It's miraculous, yes.
in the end. So I do see strangely the point, where theology and quantum mechanics, if you will, for a moment, where they come together in the end. Yeah, it's a dilemma.
Right. And carrying on with this concept of, is there a God and did he create the universe? Rupert Sheldrake, are you familiar with him, people?
No.
Yes,
Yes, he's a
the intricate
biologist,
order.
PhD, and he thinks that everything is connected in this morphogenic field that surrounds the Earth. I think it surrounds everything. I think it's part of everything, but he thinks it just surrounds the Earth. And at some point, science will delve into this morphogenic field and maybe discover it and find out and measure it and be able to merge science and spirituality together. That's where I was going with that earlier comment.
Yes. I'm not sure there's anything new there, and because I would sort of say that maybe goes back to the ancient religions and religious ideas.
Well, that's
You
the
know,
confusion. That's the confusion. The ancients confused this field that we live in. Some people perceived it more because they're more sensitive to it, whether you believe that or not. I do. And they felt that field and they felt the connection between everything and everybody. And Rupert Sheldrake has compiled evidence that, like a dog knows exactly when its owner's coming home, even if that owner goes shopping after work, and then as soon as that person decides, oh, I'm coming home, the dog knows and is ready and waiting. There's many instances of things like that Rupert Sheldrake is investigating, and I think he's onto something here. And once it's ex experimented on and studied more later on down in the years to come, maybe something will come of that, and science and technology and science and spirituality will merge, kind of not merge, but will be understood by either side.
Okay, well, I guess my response to that is to invite you to give us a talk about it.
Rupert Sheldrake, okay, I'll put him on the list. Halt Narp is up next, and that's what my picture is actually. His one of his strange galaxies.
Yeah, but this, of course, is um, I think that the I'm not really convinced that quantum mechanics is really basically a solution to the problem, as I said before, and so this is you know I'm not really sure how to really respond to this. Um,
Well, it's
Religion.
natural for
I think
scientists.
we could sort of say that we just want to talk about science. Are we talking about science, or we want to talk about religion? And they're that they were to a certain extent one sort of a category prior to Galileo and the so-called scientific revolution, in which they diverged into different paths,
Right.
and that may
Well,
have been a mistake.
you can use
Um,
the word woo woo if you want, but I mean, I think woo woo has a scientific uh, basis. It's a reality that we live in. There's so many strange things that happen on this earth and around us that can't be explained by science today, but at some point it will be. It will be understood, I think.
okay. Any other comments about quantum cosmology?
Yes, let's talk about cosmology, guys. Let me ask you another question about Paul Dirac. Do you know that he was at the same team of Nobel Prize laureates, Schrödinger and Heisenberg, Paul Dirac? And I have a question. Why this famous mathematician, developer of quantum physics, in 1937 proposed totally different story about technology. He proposed his own idea. He was so disappointed with quantum physics at this time, 1937, and he proposed this variation in gravitational constant and all this stuff. I am following his great ideas, new physics through new cosmology based on his new principles. Why nobody mentioned him as a guy who knew mathematics of quantum physics the best? He developed it. Quantum electrodynamics, it's his approach, his ideas. He was totally disappointed and he proposed totally different story. And why? You didn't even mention him. What is his opinion about this quantum cosmology and all this that stuff? He was disappointed before Penrose with quantum physics. In 1937, he already understood wrong way to go. And you're talking about right now the best theory, mathematical theory of quantum cosmology, like, this quantum physics.
Vlad, make a
Guys,
presentation.
it's a great
Okay.
thing.
Uh, that's an interesting point. I hadn't thought about that. And again, my point is, the point of this talk was basically Frank Tipler's book. Okay. And he talks about a lot of things in his book. It's phys- and it's a combination of a lot of different areas of physics. And he talks about computer science, and he talks about quantum physics, and he talks about general relativity, and all this stuff goes together in his book. Okay, so it's just a big mixture of stuff. Um, so that's I and I'm saying to myself, what is this quantum cosmology? That's really basically uh, um, my point. And I started looking in books. What is quantum cosmology? And so that's kind of my presentation is really an introduction to the subject. Now, you raised an interesting question, which I hadn't thought about. It never occurred to me why, you know, Dirac is disappointed with quantum mechanics and proposed a theory of cosmology that is not based on quantum mechanics. I think that's an interesting
Not at
observation to
all.
make. I and I would Unfortunately, he's not alive to ask him about it, right?
Yeah, but he was crazy. He was announced like crazy. He moved to America. Oh, it was failure of his life. He told in his book. I read his book about his developments, how he done it, and so on and so on. And at the end of this book, he put, it's a, I failed my life. I didn't achieve my goal. He was totally frustrated with the situation with classical and quantum physics at that time. Yes, yes. By the way, Harry, you done so great talk today. Man, I do like historical move, historical way to go from the beginning, step by step, to see how it works and so on and so on. And what is important, none of these guys you mentioned today did mention Paul Dirac, his opinion. Why he's forgot about him? He was the greatest, for me, the greatest physicist, and nobody even mentioned him in this quantum cosmology. Why?
Because he didn't agree with it. That's why.
Because he was crazy. That's it. He was named crazy, and he has to move from Europe to America to forget about this craziness in London. He was the best one at that time. He was the youngest Nobel Prize laureate in physics, and he was totally disappointed. And I believe in his intuition, in his mathematics, much more than all the other guys following after him. Boy, you mentioned all these guys and nobody knew about their opinion about the Paul Dirac. Forget it. It's my main
I think I
concern.
mentioned,
We
I
have
think
so
I
many
mentioned,
genius people in our life. I mean, physical life. And most of them forgotten.
I think I
Exactly my
mentioned,
own idea
I
about
think
the
I mentioned
cosmology.
quantum, relativistic quantum mechanics. That was
Yeah.
Dirac.
What year did Dirac come up with his equation?
That's a good question. I think 1937 or somewhere in
Then
there.
that's
Not
late.
the
Well,
years,
let's see.
1937. He got married. He came back from his first vacation with wife, and he published this paper. And everyone, oh, look at that. Became so crazy because he got married. He got married. That's it. Simple like this. They found even, solution of his craziness.
Well, the establishment liked his equation, as far as I know,
Yeah.
because it agrees
I
with
think,
relativity.
I
No,
think, yeah,
no, 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 no.
I think this is an interesting point. Um, as I pointed out, I did point out Roger Penrose, and the main reason I pointed out Roger Penrose is because he's on YouTube. He's got these videos where he says quantum mechanics is wrong, and
I,
the
I saw this.
tagline on the video is Roger Penrose says quantum mechanics is wrong. That's a big statement. I mean, I don't know if there's anybody else out there saying quantum mechanics is wrong.
I
Do you
There
know
are
of any?
people, but not with as big a name as Penrose.
No, 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 no.
Correct.
And I
I
do
mean, he's
like,
also changed his
Roger
mind.
Penrose.
I mean, he's a bit of a turncoat, one must say, because he felt the contrary before.
It's
So can I make another a comment there, a little bit different topic there, Harry?
Sure, go ahead.
Quantum cosmology. I think two times was pointed out that if you put together the smallest and the largest, right, the atomic and the cosmology, the whole cosmos, I think actually the two are causally related. If you're talking about the birth of the universe or the how it started, whatever you want to, however you want to phrase that. Meaning, if you talk about that topic, you're talking about nucleosynthesis, meaning how did the elements come into being? That is the question that you're addressing then, or at least you need to answer. So I do think that the atomic, the smallest level, if you will, the quantum level, as it's said today, does very much connect to the cosmological fundamental understandings. I just wanted to point that out in contrast to somebody else there.
Good point, Ido. Good point.
I don't know if I'm right, but that's just, I think the study of the elements, especially the lighter elements, I would argue, up to carbon, that study would shed a whole bunch of light on this topic. At least that's my real opinion.
Well, that's I didn't, I could have made a lot of presentations if I wanted to bring in all the wrinkles. Um, uh, like I said, I just tried to introduce this as just an introduction, just an overview. Um, just you know that, but the real bugaboo is the multiple worlds and the parallel universes, which seems to cause a big negative reaction to it.
Well, we
Um,
can ignore those, right? I mean, here.
well, they're trying to basically persuade you to that these ideas aren't as absurd as they seem on the surface, and so then you would accept it. Um, and then, of course, that brings in, the I don't really know enough
Okay,
about
but
it to really.
I'm sorry for the interruption, but quantum mechanics, you're talking about chance-based mathematics, which makes everything uncertain. You do not know the speed nor the location at the same time, da 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 da. Everything is up in the air. And then we bring in a multitude, a million other alternative dimensions, realities, and whatnot to make sure that nothing is certain anymore. I mean, doesn't anybody see the, you know, the
Yeah.
path to doom here? I would argue.
We understand the math. Shut up and accept it.
Right. Well, I'm a little bit stubborn there.
Well, it's just stupidity, like idiocy that they bring these multiple universes and multiple worlds into the equation when they don't exist. It's the same thing as a fourth dimension and space-time and gravity bending light. Well, it's all part of their cosmological build that they've built over the years based on this Big Bang idea and a dark epoch. Uh, it doesn't make sense. It's too
Okay,
miraculous for me.
all right. There's another topic that I didn't really talk about, which is the anthropological principle, and the problem. And what the problem is that the universe seems to be fine tuned to create life.
I would agree.
Okay. And what they do is they say, wait a minute, this is highly improbable that the parameters in our standard model and the parameters for the standard model of cosmology, they all come out in such a manner that it creates life in human beings. And there's all these other choices that could have been made, but it turns out that our universe is just this unique universe that is perfectly suited for us to exist. That's kind of the anthropologic anthropic principle, if you will. And then there's a strong anthropic principle. And this is a big problem for them. Okay. But it can answer it by saying, well, we just happen to exist in the one universe that's created that works out to be the best.
Mhm.
Hmm.
Religion.
Yeah, so you're back to religion, right? Exactly.
Yeah. And what is important, instead of physics, what we discuss right now, mathematics. Mathematics. There is no physics at all. They took some approach, mathematical approach, and they're trying to apply it to physics. It doesn't work. It didn't work for Paul Dirac in 1937. It doesn't work for Penrose. Nevertheless, a lot of people, they're much smarter than these two famous guys, and they know that quantum physics does work. Forget it.
um,
And you know,
I,
you
I think, yeah, to a certain extent, the real problem boils down to, like I was touched on, this dilemma of classical physics versus the quantum physics dilemma, which is, quantum physics, it really just deals with, ensemble averages. Okay. And so but classical physics sort of deals with the idea that there is a reality, there's an objective reality out there, but quantum physics doesn't have that objective reality out there, so to speak. So you're dealing with a different philosophical orientation, and they've abandoned the idea that there is a reality. And I look at it from the point of view of what you're saying, Vladimir, of physics. Okay. Physics is what is the real world out there, so to speak. So originally it was what is the real world? What are the physical laws that govern the world that we live in? And that world is a real world. But quantum mechanics has come along and says that the real world isn't really real until the observer observes it. And so
yes,
the real world only exists because we're here to see it. And to me, that's just, go ahead,
And,
Ian.
and is it a coincidence, Harry, that roughly simultaneously these two concepts arose on the macroscopic level in regard to, say, relativistic theories, and on the microscopic level relative to quantum theories? Complete departures from classical determinism and logical Grecian, type thought. Now, is it a coincidence that those things occurred at the same time? So one could be a bit fanciful and introduce something which is not physics, but is sociological. One could say that there was a breakdown of the old order. Just as in medieval times, you might have had religious wars and so on. But here you had a breakdown in the sort of Victorian society, and you had revolutions and the Russian Revolution, and they're all occurring around the same time at the beginning of the last century. And these two theories arose roughly simultaneously. So is it a sociological thing which allowed people to imbibe these seemingly contradictory ideas? Because is science so objective, or is there really a societal element such that it would not subsist at all unless the general development of society would be amenable to it? And I'm talking about things like politicians and economic circumstances and even wars and things like that. It just seems so illogical, to us. We're dissecting it, and it seems obvious to us that one should talk about these things. But no, they've been verboten for 100 and more years.
The nucleus, the atom, the neutron, was accepted as a fundamental particle in 1933 at the Solvay conference in Brussels. That was a gathering of people like the Bohrs, the Einstein, the Heisenbergs, etc. et al. That's when the fate was decided, and ever since there was, dissent was no longer allowed, if you will, and everything became quantum mechanics. That was the birth date in my mind. Not the birth date of quantum mechanics or certain variations of it, but the acceptance of the fundamental principles relating to the atomic realm, if you will. So hammering the fundamentals down, and ever since nobody talks about the nucleus anymore, even except people like me. I'm just pointing that out.
Well, a similar thing happened with Einstein's relativity with the Solvay conference. I think that was in 1913 or something like that. They just, it was declared Einstein's theory is correct, and so no dissent is allowed after the official proclamation has been put forth.
That seems to have been the function of the Solvay conferences, if you look at it in hindsight. Yeah.
The Pope has spoken.
Yeah, well, that's another way of I think to a certain extent, somebody at the top has to make a declaration in order to get people to cooperate to work together towards a goal. Otherwise, they work towards different goals and nothing gets accomplished.
Well, science is consensus, basically. I mean, it's always been that way. Go
Okay, I
ahead,
see
Roger.
What you're
Roger
saying
wants
in a
to say
way
something.
is that these are the modern equivalents of synods or councils. The Council of Nicaea determined what should be the essential elements of Christian faith, and they had to argue against other ideas like Arianism and so on. But the council decided, and that's it. So now we have the Council of the Solvay Conference or the Council of the International Astronomical Union or whatever it is. It's the
Agreed.
modern equivalents of ancient theological councils.
Hi. Hi. So
All right, Roger wants to say something.
I don't understand the human input into the sciences and physics, because it's supposed to be that physics is not about voting. You don't vote for something, but they do have these conferences and they do have a vote sort of thing, and then that's dogma for afterwards. So they're saying one thing that they don't vote, and then suddenly there's some secret vote somewhere where they've decided what physics is going to be. So
Yes, and in the case of relativity, it looks like that's just an unshakable mistake. What Einstein said is cast in concrete, and they had the conference of Nicosia for physics at the Solvay conference, and once it had been declared, this is the physical reality, and we're all going to adhere to this viewpoint,
yeah,
then it's cast in concrete, and all the criticism that's been directed at it afterwards has had no effect
yeah.
whatsoever, it
Well,
looks like.
in the case of relativity, there was dissent against it, but those people just got discarded as being idiots, or they didn't understand it, or whatever. So their point of view was discarded. So when it comes to the voting, you sort of like say, well, how many voted for relativity and how many voted against relativity? Was it, say, 50-50 or 60-40 or whatever number? So they don't tell you how many people voted for it and how many people dissented. It's sort of like
So crank is the new term. I'm looking at the analogs between
yeah,
the theological and the scientific. Crank is the new term for heretic. They don't say
yeah,
you're a heretic; they say you're a crank. But in the theological sense, 1,000 years ago, they said you're a heretic.
yeah,
So
Well,
now it's a
Roger,
crank, not the
Roger,
same.
I would suggest to you that it wasn't, the entire group of physicists that got together. I think it was probably the most the top 10 or top 20, and those are the people that said consensus
yeah. Well,
matters with
we don't
us only,
we
and
don't know
and
how many
listen to
people.
us.
It's sort of like we don't know how many people voted for relativity and how many people voted against it. It's sort of like, why is that? Why don't we
10 or
get the
Well,
20
numbers?
people. 10 or 20 people, that's
Yeah,
it, I'm guessing.
They,
Yes.
they had a meeting and sort of suddenly that vote counted for the dogma of physics thereafter. It doesn't make sense. People don't make
And
sense to me.
and everybody below them has to
Yeah.
follow them.
I sort of I can ask AI these questions, which I can't find out in the literature, and I ask it for how many people sort of like voted for relativity and how many didn't, and there's no record of it. There's
Right.
so people are just doing things in physics, and then they're not keeping a record. I mean, it's sort of supposed to be the dogma that physics theories are not decided by voting, but they do it by secret votes.
Well, that's one thing that AI can't do is personal interactions between people and groups of people
Well,
unless it's all written down for it.
yeah, they don't even keep a record of the voting. They don't, so you just have some meeting. They voted for relativity. How many people voted for and how many voted against? Oh, there's no record.
Are
It's
we
just
sure are we sure it was a vote or what,
well,
or whether
how
it
do they?
was just a group of, well,
No, well,
you can just have
Yeah,
a group of people that agree,
yeah. Well,
if
and
you
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 don't
read
don't
even
know how
have to
many
have a
people that
vote.
is. That is a
when you
vote.
Well,
That
if
is
when you
everybody's nodding their head while you're talking, then you got a good
yeah.
understanding of
Well,
how many people
they
agree.
do they do tell you to put your hand up. Say how many people agree with this. How many people don't agree at the conferences I've been to. So they sometimes take a head count, and suddenly in these secret meetings, they've suddenly had some sort of head count of who's going to go along with it or not. So they've had a vote, and we're not being told where this vote was.
I agree.
And so it's just
Well, in the modern conferences, they do have votes, yes.
yeah,
And of course, the most famous incident was when they voted that Pluto wasn't a planet.
yeah, that don't make sense. I disagree. I mean, they use the
But I
term,
think this explains the point I want to get to here is I think this explains why there's so many videos on YouTube by David Deutsch
yeah,
and Sean Carroll and these guys. That's part of the propaganda.
yeah,
They're appearing in on these videos. They're going to these conferences. They're giving speeches. They're explaining to everybody why the parallel universes idea is reasonable and we should accept it, or the many worlds interpretation is reasonable and we should accept it and it's good physics.
yeah.
And I guess if they appear at enough conferences and convince enough people that this really makes sense and it's not
But
illogical, that
that
then it
that
will become.
that is a propaganda campaign. So who's funding that? Who's got the money to go around funding, going around to these
The
conferences?
universities.
Well, it's so like, why are they funding that point of view? And then you've got the same thing with climate change. Who's managing to fund that point of view? It's all sign of, oh,
The
somebody's decided,
globalists.
if somebody's
well,
decided to promote this science and they put money into doing that.
they don't have to try very hard because once an idea has taken root,
Hmm.
uh, it's not difficult to find people who want to promote it to advance their own careers. You know, some of these people that you've just talked about, I mean, I've read some of their books, and they seem to be just spewing out the um, common, commonly accepted doctrines as their own
Yeah.
to advance their own positions. So it's a bit of a circular thing.
Yeah, well, the
Well, I think
money's
he
got
was
to come.
Okay,
asking. I think he was asking who's funding these studies that are saying that the Earth is warming up due to human influences.
Yeah.
Well, the governments are the
Yeah.
countries
Well, they
and
start,
the UN. You can
they,
see
they,
the
they,
No,
they,
UN,
I
which
would
they,
yeah,
I
you
would
might
say
imagine
more
has
the
nothing to do with it.
universities and the globalists that pump money into the universities as well.
all
The
right, we're coming
banks.
up to the end here. Um, I'm not sure that's really relevant to our discussion today. Okay.
Call me conspiracist. I don't care.
Well, that's another issue. I think prop, that's a sociology of science.
yeah.
All right. Okay, that um I think we got sort of into how our decisions about what is good science and good physics are decided upon. And I guess that's a kind of a meta question, if you will, and not really relevant to the topic that I was
Well,
talking.
the thing is, say, going back to a relativity example, they funded relativity as a research thing, but they didn't fund the dissent against it. And that's what's killed the dissent against relativity. It wasn't funded.
Um, yeah, but I think in the universities, the professors can do research on their own. You have a chair in a university, and you're allowed to do whatever research you want.
Yeah. But say it's Lorentz theory that didn't get funded the same way as Einstein's relativity. So there wasn't a Lorentz school set up. It was only just an Einstein. It's sort of like, where's all this happening? You're not getting information about why these things are being done by humans.
Money goes to the so-called best ideas.
Well, that doesn't really work, does it? Because Lorentz had some good ideas. So they decided to ignore that, and they went with Einstein's ideas.
Well, they
They're just
considered them
prejudiced.
better than Rancid, right?
Sorry.
Well, I think now you're getting into the question of, are the deans in these universities heads of departments in in the university system? This is where their power comes into play. I
Yeah.
mean, I would think that if you're promoting Lorentz's theory, the department head of the physics department would call you in and say, well, this isn't really good physics,
Yeah.
and you're not really doing a service for the university to be promoting the Lorentz theory when it's well known this theory has been disproved.
Well,
Agreed. And the
then
same thing
it's
happened at Halton Arp.
yeah. And so,
Yes,
They
Halton
took
Art
his
is a
telescope.
more public
but
example. Yes,
like
Yeah.
the dean is under pressure from above, like, oh, you won't get funded for your university if you do go for these maverick studies. So that's his pressure from above, even. So it's somebody further on up from him.
Back to reality, which is kind of in that 1 to 2 bit range.
What's going on here?
Yeah,
is that Cornelius?
No, it's Jim. He just muted himself.
Yeah, okay. So it's people. People mess up science.
Well, I think it's well known that science is a human endeavor, and that that it's certainly true that the money and the funding is real important, at least in today, and the way the universities work. And there's the funding and the money is certainly real important. Um, um, but I'm not
Yeah.
really sure that's really within the purview of our
Yeah.
discussion.
You go on the conspiracy side. There's
Well, the real issue though
yeah.
is the question to ask about quantum cosmology and quantum mechanics is why are they promoting? To me, my view of it is you have a bad theory, which is general relativity, because that's based on Einstein,
Yeah.
and the idea that time and space are relative, which that doesn't really make any sense. And so you got a bad theory there. And then you've got quantum mechanics, which looks like it's another bad theory. And they've been trying for 50, 60 years or whatever, trying to make them work together, and they can't get them to work together. And now one of the things I've noticed on the internet about this DeWitt Wheeler equation, the they're claiming that the DeWitt Wheeler equation proves that time doesn't exist. And so you've got a theory about time and space and a theory of quantum mechanics, and you combine them together and you get the DeWitt Wheeler equation, which supposedly quantizes space time. And then they say, well, this shows that time doesn't exist.
Great conclusion. Thank you so much.
I mean, this is the sort of thing that they say, and these are the kinds of, I mean, how does any of this make sense?
Yeah. Well, they call it voodoo science or something now, don't they? Woo woo. So they're just making stuff up.
Well, you're getting to the question of what is YouTube really a good source of scientific information? And the answer is sometimes yes, and sometimes maybe not.
What-
And so, I mean, so I sort of question, when somebody is sort of saying the Wheeler-DeWitt equation shows that time doesn't exist, I sort of,
who,
scratch
who
my head.
who's that? Is that Deutsch? Is that David Deutsch?
No, that's just one. I've seen this on YouTube in a couple of different videos, and I'm not really sure where it comes from.
Yeah,
And so I'm just bringing that up as, and it sounds pretty plausible, you know, but really what they're doing is they're taking time evolution out of the physics. So in other words, they're treating the universe as what they call in relativity the block universe theory,
yeah.
which
It's
is
Einstein.
that we treat time from the beginning to the end as a
Yeah.
single entity, and we don't really it, I can't really explain it because I'm not really.
Well, it's
But
Einstein on that anyway. That's
Well,
not,
so
so
Sabine,
time becomes a non-parameter. So there's no evolution parameter in the universe. The universe is just taken as a whole existent thing. The
yeah,
time from beginning to end is a whole thing,
yeah,
and then so time ceases to exist in that viewpoint because you've taken it out of the equation, so to speak. So,
yeah,
so
But
does
they're
that
also
really?
saying that the past and the future exist now in the same way as the present
Right,
does,
right.
simultaneously.
yeah,
Kepler talks about this in his book. That's one of the things that he talks about. That's a technique that they use in cosmology, and it's kind of one of these things that you have to really read about it, and sort of dig into it before you understand what they're talking about. I can't claim that I understand it.
yeah.
So, Bob, you haven't said anything.
Well, I don't know here. Yeah, this one with Everett, I've come across that one a long time. There are other interpretations of quantum mechanics besides that, like David Bohm's and things. Yeah, one thing my model actually that my thin shells has sort of in common because I have parallel fields. Uh, but as far as I can see, when they talk about these parallel universes, it's not clear that there's any interaction among them. When you supposedly make a measurement, the universe splits and stuff like that. Whereas, at least with my fields, when I have a four-dimensional particle, it it goes through all of them, and then what I think collapses a wave packet is absorption. Uh, and you don't have to bring in consciousness or anything for absorption, and it occurs right in the eye and the retina, like with Rhapsodin and stuff. And uh, I'm not sure that entirely works. I've heard counterexamples like with superpositions of atoms, and I'm not really sure how to handle that one. But many superpositions you can get like with parallel fields at least. So I have that much in common, I think, with this move of parallel universes. But for me, if they're just independent, I don't see why you want to say that any of the other ones exist.
Yeah, I have to point out that David Deutsch, there's different interpretations of this idea, and so they've sort of refined the argument to sort of take away some of the points that you made.
Yeah,
Um,
but with
but
Deutsch, Everett, as far as I know, didn't talk about parallel universes. I know Deutsch does. I've known of him for quite some time. But
yeah, I, I thought about I'd look into this and sort of maybe try to make some sense out of it, but then I decided that's such a big topic that it really was not really something that I could really talk about.
I know
in
there's
a
an early anthology of papers on Everett, and I think it was co-edited maybe by DeWitt, and you might take a look at that.
Yeah, DeWitt, is another proponent, I think, of the multiverse idea. And he also, and what you said is correct. DeWitt was involved in writing. There's a Princeton book that DeWitt wrote about. So DeWitt is another proponent of the many world. But the point is, it's not clear to me whether the many worlds interpretation introduced by Everett and the parallel universes idea and the multiverse idea. It's not really, it seems to me that these are all kind of variations on a theme, if you will.
Yeah.
And there's so many different ideas, that people are talking about that it's not really a consistent thing that you can really say is wrong because of X, because there's,
Well,
they've
it's their solution to the measurement problem. When they say there's no collapse, you just split universes with different variants happening.
right. That's a simple way of looking at it. And yeah, then you say, well, the real issue is that the Schrodinger cat issue, which is why do these multiple worlds exist prior to the collapse of the wave function
Cat's
to
alive
begin
in one
with?
of the universes and dead in another one. But
Right. That's a
yeah.
simple answer to it, but it doesn't make sense. That's
Yeah.
it's and then, then people say, well, the problem is superposition. But if you criticize superposition and try to get rid of it, then quantum mechanics doesn't exist anymore as a theory.
Yeah, but I think you kind of need superposition to explain interference.
Right. That's the whole point that they're at. Yeah.
Yeah, and interference is
And
a genuine phenomenon.
right. So they're saying, well, we can't get rid of these ideas because then we can't explain the experiments with the ideas. So, so they're in a catch 22. Right.
Mhm.
But I like Fadimir's idea. Let's just ditch it and go back to classical physics.
Yes, guys. But by the way, Jim, you didn't tell any word today. I want to know your opinion about it. You're almost very active always. And today I didn't hear any word from you. Jim, please tell your opinion about this.
Well, Vladimir, hello, and thank you for
You
that
know,
invitation.
oh
Can you
yeah.
hear me?
Yes.
Yes, of course. I would
Okay,
like to know
well, what has been
your
left
opinion.
out, I think, thanks, Vlad. What has been left out today, I think, is the clinical psychology um, point. And that is that when we talk about all of this chatter of different ideas, it's really the kind of thing that one would hear in an insane asylum. When Robert talks about instances where people make an act of measurement and that is thought to create a whole nother universe, that is what we call megalomania. Okay, so in Harry's list of the names of people involved in what we have been calling today quantum cosmology, as if that's actually a legitimate topic in the first place. These people seem to be exhibiting a variety of psychiatric symptoms, including schizophrenia, megalomania, as I mentioned, and so forth. So that what is missing, I think, in today's presentation, and thank you again, Vlad, for the invitation to comment, is clinical psychology. There's a whole lot of subject matter in today's talk and the comments about it that really fall under the aegis of clinical psychology. We can't leave that out because we got a whole lot of it, a whole lot of subject matter in that area in today's talk.
Functional
Which, by the way,
psychopaths.
was a good one, Harry. I think Harry did a great job.
You did
I
a
was
great job.
going to call
Yeah.
quantum mechanics a religion, but this is better. Thank you, Jim. Good comment.
Not a religion, it is mathematics only. There is no religion behind mathematics. Forget it.
Well,
Math has
I'm not
become its own
bringing in the
religion.
religion angle. I'm not bringing in the religion angle. I'm saying that there's a whole lot of clinical psychology material in this content that we've been talking about.
Well, I brought in sociological questions, and you've brought in individual psychological questions. I think they're both relevant, actually.
Agreed.
Well, I'm standing at the top of the pit where the mathematicians are down, way down in the hole, digging away, talking to each other, and I can't understand what they're saying. I can't even hear what they're saying. So that's my point of view from math being its own religion.
Well, I think the issue here is that is the mathematical technique that they're using, that they've discovered, gives them the most accurate predictions of any physical theory, bar none. Um, when you have this mathematical procedure that works so well and works so brilliantly, they basically have a problem trying to understand why it is that it's not working correctly, in these issues that arise, that produce these absurdities. And they've got a real problem, which is, we're doing physics and we've got this great mathematical theory, but we just kind of got these problems with what happens if we interpret it in the measurement problem. So they have the measurement problem and the interpretation of the measurement problem, and they're struggling with how to resolve the contradiction that results. And they don't see it as a contradiction, they just see it as a problem to be resolved somehow.
I will argue that a tiny part of the answer is that some fundamentals are simply wrong. The probability again. So from my own perspective, my own little forte is the nucleus. In my mind, the nucleus is static and organized, meaning a specific structure. The quantum mechanic world describes it as a probabilistic something, and there is a boatload of models there, but they all have this non-understanding, if you will, of the organization. So you're left with a statistical chaotic system that you have to describe that way. So think of the chemical world, whereby certain molecules have angular, there's an angle to the specific chemical connection. If you're going to describe that in quantum mechanical statistical terms, you're going to have problems, right? You're not be able to do it. So my whole argument here is, from my own perspective, is that certain fundamentals are simply wrong. But again, and then we're back to the beginning, they are not allowed to be addressed. That you can't touch it.
Right. So
but the problems are there.
It's to my thinking, it's an abandonment of classical principles. So you abandon some principles of classical physics. And Roger, in his presentation yesterday, I think, described a bit about how that happened. And that is, Einstein brings the observer in and saying that time and space are relative to the observer. They're not absolute or objective outside of the observer. The physics becomes observer dependent. And then quantum mechanics comes in and makes it that reality is what an observer sees when he makes a measurement. Okay. And that's kind of stepping away from classical physics ideas. Right. And I think that's where the problem arises from. And to convince them that this is a mistake and they shouldn't have done that turns out to be something that they don't want to hear about.
Well, I would argue what you just pointed out is actually completely at the heart of the problem here, and it is a charlatan trick. If you confuse the observer with the observed, right, then you confuse the time perception element, and then you're left with, something moved in time. No, it is utterly ridiculous, and anybody can show that and prove that. But it does go at the heart of it, and it's a charlatan trick. So one could argue there is some nefarious component at work here. I mean, how can you make that mistake at this level if you're talking the top scientist of the humankind? If that is the state of the humankind, I greatly, greatly worry. But there you go.
Well, there's Jim's solution to the problem, which is that they're crazy.
Which is what? Sorry?
They're mentally defective in some way.
They're
Okay, but I still
deranged.
worry for the humankind then, because apparently we are following those types. So, problem.
Yeah, I think the issue is why don't they're so enamored with the idea that, and I heard this, you hear the same story in special relativity. The special relativity is experimentally proven thousands and millions of times. It's one of the most thoroughly tested and proven theories. Special relativity is correct. General relativity is correct. And millions of experiments have demonstrated this. And they say the same thing in quantum mechanics. It's the most accurate theory known to physicists. It's the best theory, the most accurate theory, the greatest theory. All the experiments demonstrate it, da 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 da.
We even
And
see the Einstein cross out there in cosmology, even. I mean, it
right.
proves it.
And so basically, that is a defense. You can't. So then, when the theory produces absurd results, quantum mechanics, you've got these parallel universes and things that don't really make sense. That it makes sense to them because they believe the theory has to be correct. The theory is correct. We maintain the theory is correct. If you're a good physicist, you have to accept these things are true and correct. And here's the implications that you get if you believe these things. And the implication is parallel universes and indeterminism and all these other problems that arise if you are going to adopt quantum mechanics. And then if you adopt special relativity and general relativity, you have this problem that time is relative. It's not really well defined. Each observer has a different time experience, a different space experience, et cetera, et cetera. They don't see these things are a problem because the experiments are 100%, thousands of experiments are proving them correct. And so they're in a box.
And they also say, and this they would claim is a very strong argument in their arsenal, that it might appear at first glance to be illogical and so on, but
Oh,
our
that's it.
whole technology is based on it. You wouldn't be able to have a Zoom meeting, you wouldn't be able to have TV, you wouldn't be able to have mobile networks, you wouldn't be able to do anything in the modern world. You have motor cars, everything is based on this. All our technology is based on this. That's what they say.
Yeah, this
Yeah,
is
it's
the
kind of
kind of
hard
thing
to
that
refute.
this is the
Pardon?
kind of thing that you see and hear in psychiatric wards. I mean,
Yeah.
this is not unusual at all for psychiatrists and clinical psychologists. This is a well-known thing, and you hear this kind of chatter about multi-worlds and so forth. These delusions in psychiatric institutions.
It's just that the converse applies now because they consider these people with these delusions, as you call them, to be normal, and people like us who question them to be psychiatric cases. It's
Good
reversed.
point, Ian. I love it. I love it.
Well, Robin Hood was a madman, as you know, right? Um, how dare you stand up to your earl or whatever?
King John. Yeah.
Yeah, that one.
Another thing about this obsession with math that is a thread in many of the presentations that we have here on Sunday, thanks to Harry. Uh, actually, if a 4-year-old pre-kindergarten kid doesn't know the math, then it's irrelevant. All of this more complicated math. I mean, math itself is a huge field. They got their own journals, they've got their departments in universities. It's a big thing. But just because someone comes up with a math theorem or a co-equation does not mean it has anything whatsoever to do with physics or the universe or cosmology, period. In other words, well, as I think everybody here knows, in binary mechanics, cosmology, the only a 4-year-old knows all the math because it's part of language. Language has the math of idea of yes or no, the binary digit, and the and function, Jack and Jill went up the hill, and the not function, I did not do it. So even a 4-year-old understands the math required in physics and cosmology. Anything that a 4-year-old does not know, you're on dangerous ground, and you're probably hallucinating. You're probably completely hallucinating. And to even discuss it brings up a real question of mental coherence and integrity. I'm using the word integrity here to mean, are things functioning properly in one's brain? So the fact that we spend so much time talking about math that has nothing to do with physics or cosmology is itself a real issue, I think, in these discussions.
I'm not crazy. You are.
So the bottom
Could be.
line is the bottom line is the universities are full of cranks and who don't know what they're talking about, and they're crazy, which is not really a proposition I would disagree with. But I think Vladimir makes the point. He said, this is not physics. They're not really doing physics. Um, they create a theory, and the theory is not really physical. It's imaginary. And then they done a bunch of experiments and said, oh, the experiments agree with our theory, therefore the universe is irrational. And we have to accept that the universe is irrational because this is the way we explain the results of the experiment. And it never occurs to them that maybe they made a mistake somewhere along the line.
What Harry is saying here, I believe, can be characterized as the voice of sanity. And if I may just take a moment and ask Roger Anderton, I think he's doing, in conjunction with Harry, a good thing by posting these videos on the internet and in YouTube. And I'd like to ask Roger, if he wishes to chime in, what kind of exposure are your videos getting, and these Sunday meeting videos getting? Are there a lot of views or what, Raj?
So, something right about under 100, I think. The trouble is, it's the initial number of people watch them, and then there's no follow on later.
Well, I think even, it may sound, thank you, Roger. It may sound like a small number, 100,
Yeah,
but these are relatively technical material. And I think 100 views is something quite good.
yeah, it's a bit under 100, but it's sort of like you get initial lot of viewing, and then it doesn't seem to be any more after that. I mean, like look
I
at
see. So they don't seem to have legs, as they
yeah,
say.
but it doesn't carry on. It needs to be a big publicity campaign because sort of like when Einstein became famous, it was a big publicity campaign in the newspapers about him being a genius and all that. And without a big publicity campaign, you're just not getting out to the general public.
Well, thank you, Roger. I think you're performing a good service here, sir.
Yeah,
Thank
There
you.
don't seem to be that many attempted rebuttals in comments. I mean, I might have expected a lot of comments, very hostile, saying you're
yeah,
a lot of lunatics and so on. So I don't know if people who are totally wedded to the mainstream, just couldn't be bothered going to it. They said such crank stuff, I won't even bother. Or if some actually are not so hostile as one might imagine.
I think there's a crank watch website, and they just slag things off there. They don't even bother to go on the video. They slag it off to these members. So you've got the mainstream people who believe things, and they've already got their big group, and they're already just slagging things off and CMPS and already and telling everybody
Roger,
on
just out
there
of curiosity, which videos had the most views? What
what
subject?
from what we're doing. Uh, from what we're doing, you mean?
On your site.
Yeah, I'll look it up.
All
Oh,
right, we got just a few minutes left here.
okay.
Um, uh, let's see, got 8 minutes. Um, I know
Analytics.
that Jim sort of approves of my little tirades, but I don't think that the physics community is really that interested. They're not interested in criticism. They're not interested in, and I noticed when the Saturday morning, yesterday, there was a guy that said, "Well, I looked into Ron Hatch's papers, and they're not that. Oh, they're," and then that caused Dennis to get involved in a big long talk about Ron Hatch and I don't really see that really accomplishes anything. And because they're not listening, and I don't think they want to listen. And so I think we're really just basically talking to ourselves and amongst ourselves. And I think if we understand, my goal here is to really basically help people understand what are some of the issues, and particularly in the case of this issue of quantum cosmology, it kind of does produce these things that don't really make sense. The parallel universes and the multi worlds. How can you apply quantum mechanics to the entire universe and have it make sense? I don't know that there's an answer to that. I don't know that they've been successful in doing that. Maybe that at some point in the future they'll have a big breakthrough and they'll be able to apply unify. They can't unify quantum mechanics and gravity. They've had years and years and years of trying to come up with a quantized theory of gravity without much success. They're you'd think that they'd stop and say, wait a minute, this is not working. Maybe we should go back to the fundamentals and rethink things, but that doesn't seem to be the way they're approaching the problem. They seem to be thinking that if we just keep working on the problem, we'll stumble across a solution and a savior like Einstein or Stephen Hawking will come in and show us the way forward, and then everything will be great, and we'll have this great, wonderful theory of everything, and it'll all be solved. But so far, it's not happened. So I think that's the question. When are they going to realize that they're beating a dead horse? And they don't seem to be arriving at that conclusion, and they don't seem to be thinking that they're going to arrive at the conclusion. I don't see them questioning where they're heading so that they would basically stop and say, "Hey, maybe there's a problem with quantum mechanics." That's been around for a long time, and all these problems have been around for a long time, and they don't really seem to be questioning the fundamentals. They're pretty much wedded to the whole thing, and I don't see a change coming anytime soon.
Well, one earthly explanation is that from what I was taught within the Leonard realm, so in cold fusion, if you will, that inventions such as a cold fusion apparatus needs patenting, needs licensing, needs approval for markets, etc., etc. Now, I'm not an expert in that field at all, but from what I understand, it is based on what is accepted within the scientific realm. Meaning, if something is not accepted in the scientific realm, i.e., cold fusion, though you cannot do it. When you don't get your funding, you don't get your approvals, and you don't get your development process. So this is something that is why it is important what is accepted within the scientific realm and not. It does have a link to the real world.
Now, there have been breakthroughs in the past where the inventor upset, the whole scientific consensus.
Paradigm
Right.
shift.
And they do cause paradigm shifts. The issue, the problem is that these inventors and people who have done this really had to struggle against the current opinion. Um, I'm not working on such an invention as it stands, so I'm not sure I can affect that. Um,
Okay.
I want to talk a little bit, guys. Thank
we're
you so
coming up
much,
to the
Harry,
end
for the
here.
great presentation today. But what is important, it's a very good example what we must do in all our group sessions. If we don't need to prepare only our own ideas or theories and so on and so on, we must increase our educational point to have to go with some other ideas, with some interesting approaches, with some different authors. It's a very I do like today's session because we all grew up with a new ideas, with a new approach to cosmology. Maybe somebody else will present not only his own ideas, but somebody's idea for discussion for the whole group. It's a great example you gave today, Harry. Thank you so much for it. Let's follow your proposal, your first very great session today with history of physics with different ideas not belonging to us, to somebody famous, and why it goes, why so go, and so to some evaluation what really we have around.
So 3 presentations came out of this presentation. Is that what you're saying, Vlad?
Yes. Let's follow. It's a very good example, guys. I enjoyed today. I knew nothing about this cosmic, gravitational cosmic. I don't know how to name it, cosmology, because I don't believe in it. But what is important? What is important? It's a very good example for the beginning of our discussion and to take the different, ideas, different approach to the same theme of the presentation. Thank you so much. I enjoyed it today.
Uh, so
Well, I thought people would go ahead. We
I
got
think
like a minute.
I think Isidro Carl's talk has got the most views. It's 89 for the past 90 days ago. Then it's followed by the Electric Universe talk.
I've seen one talk about gravity waves had 270 views.
On mine.
Hey, we're gonna get. I want to thank everybody for coming today, and thank you for your kind thoughts. And I guess basically accomplished what I wanted to accomplish, which was to introduce a new idea and a new concept, so people could at least have some kind of idea when they hear about parallel universes and multiverses and quantum cosmology and this sort of thing, and listen to David Deutsch and Sean Carroll and these guys on YouTube pontificate. They have some kind of background to understand what's going on.